Right, this video is all about averages, and the three you probably heard about are mean, median and mode. So first of all, what do we mean by an average? We use it to give an indication of whereabouts our data values are clustered around. So why have we got three different sorts, and where might they be used? I'm going to use an example that you've got a clothing manufacturer, and he wants to know what clothes he should produce for a group of young girls. So he's taken a sample of young girls and recorded various things for them. For illustration, we're only going to have a sample of 10. He would have taken a much larger sample.
Okay.
He's measured their height, their shoe size and their favourite colour. And we have the data here. Bear in mind that I have taken each column and rearranged it in order, in numerical order, or grouped it together so that each row doesn't actually reflect one particular girl.
Okay.
So we've got our heights in order, then our shoe sizes and so on.
Okay.
Let's deal with height first of all and look at the three different averages. The mean in this instance is what we call the arithmetic mean, where we've added up all the values and we've divided by how many there are. And we end up with a value of 164.6.
Okay.
Which is right up here. We can see that the mean isn't really reflecting that the majority of the values are here in this instance. It's been slightly distorted by this pair of teenage girls who happen to be quite tall.
Okay.
The median is the middle number if they've all been arranged in order. We've got 10 values, so we've got to take the value between the 5th and the 6th. And that comes out as 162.5 between these two.
Okay.
Which is actually, in this instance, a much better indicator because it doesn't get distorted so much by these larger values. And then we have the mode, which is the value that occurs most often. And here it's 162, which is a bit low because we have got quite a few others here.
Okay.
So in this instance, it appears that the median is probably the best value to use. If we hadn't got extreme values, then the mean would be a very sensible choice.
Okay.
Let's look then at shoe size. We've got different type of data here, but we'll look at that in a moment. If we just add up the values and divide by how many there are and get the mean, we get 4.3, which in this instance is actually meaningless because it doesn't relate to an actual shoe size that you can make.
Okay.
So we have a problem with using the mean when we're looking at discrete data. Although shoe size is measured on a scale, it can only take set values. So it's discrete data as opposed to height, which can be measured against a continuous scale.
Okay.
So let's here look at what we get for the median. Again, if you take the mid value, it's between these two, 3.75. Totally meaningless in terms of the context of shoe size. So what's the mode? 3.5, which is what most of our girls, the size that they take. And if you're manufacturing shoes, you want to know which size you're going to have to produce most of. So in this instance, again, the mode is quite a useful one to know about. What about their favourite colour? Here I've grouped them, so we had one person giving blue, two giving red, two giving yellow, and all the rest gave green. This is categorical data, has no numerical value at all. So the mean and the median have no context at all in this situation. The only one we can consider is the mode, which is green. That's the value, the colour that most of the girls thought was their favourite, and that gives useful information to the clothing manufacturer that he can consider a range of palettes centering round green rather than round red or something like that. So each average will have its own context. We've got continuous data, discrete data and categorical data, and they all have different characteristics.